so what if you want to do something slightly more advanced to this? Now, I was talking about doing a red and green man for the pedestrian crossing. But in this video, we're just going to look at the functions that you might want to make a slightly more advanced program for. So we're not going to have red and green man. That's just extra detail and timing when different lights come on and off. But you'll want to put them in for your full A grade if you want to get that on the traffic light assignment. But anyway, what can we do to make this slightly better? So first of all, it just goes green, amber, red, and then back to amber. But on a pedestrian crossing in the UK, you've got a flashing amber light. So we could have amber on for half a second, amber off for half a second, amber on, etc. 5 or 6 times. But it's nice just to do something a little bit neater. So let's just see what we want to do. So let's give an example here. One other thing I didn't mention in the first video, but when you've got this T symbol here, that means toggle. That means if it was on, it'll switch it off, and if it was off, it'll switch it on. Now here we're just going to have a half second flash, so that one, amber on, and amber off here, so they're all off like that. Okay, now we could copy and paste that 5 times, or we can use what's called a for loop. So that means for 5 times do this. Right, so double click on this and you've got a number of options. You can either do this loop for a set amount of time delay, or a set amount of counts. In this case, we're going to do 5. You can choose the amount of times using a variable for this thing, or you can change the count if you want alternating sequences, slightly more advanced stuff. But here we're just going to do a basic repeat 5 times. And then we'll want an end loop, so it knows it's just this bit within these. It's almost like square brackets. In these brackets, just do these bits. Now we can just bring this, so it goes amber, red, amber. So we can just slip this in here, like this. That's fine to do that. We might want to redraw those arrows. However, I'm going to show you another thing that's quite nice, and that is what's called a subroutine. Now, let's say you want to have the flashing lights. In the case of pedestrian crossing, it's not the case. But let's say you want to have this light flashing whenever you hit a penalty or something like that on a game, and you want a flashing light to say penalty. Then whenever you want to call that penalty in your main program, you can just have this sequence that is just called. So rather than having this thing every time you want to use it, you could just have that subroutine, which is this thing here. Now we've got 2 things here. First of all, the subroutine, and then the return. Okay, so this is like a kind of separate program which will happen whenever it's called here. So whenever I call this subroutine, it will play this. Now you can have many different subroutines, so in that case we need to name them. This one is flash amber. Okay, now if you label it first on this one, then when you come to use this one, you can pull down the option, it's there. Okay, and you could potentially, instead of using a loop thing, you could just call that subroutine 5 times. It's 2 different ways of doing it. As with coding, there are often many different ways of doing the same task. So yeah, 2 useful things. For loops, while loops and until loops are similar as well. It's while something is happening, do this. So if you've got an input on, for example, where the button's pressed, this happens. And then until command is basically something happens until like a variable gets up to 10 or something like that. Now you can use that in a similar way to the for loop, but yeah, it's 2 ways of doing it. Okay, so this will give us a much, well, we should now have the sequence as before, and it's still quite a nice compact little program, but now we've got something that's slightly more advanced. Okay. Now, what if, on the final example, in real life, you might notice if you press the Pelican crossing button and it's just happened, then you'll have to wait a little bit for the traffic to pass through. It won't always favour pedestrians. There might be some times when you've got 30-second wait to let the traffic go through before you get your next chance to cross the road. What happens there? Well, we can count. We can count up a time. And here, as you can see, we've got loads of different options here, and we'll get through some of them in due course, but we're just going to have a few basic ones. I often get lost on the list, but somewhere we've got clock. There you go. That one there. Now, what we might want to do is start counting. So let's say when when this cycle has finished, we're going to start counting here. Okay, so set the clock to 0, start counting. So we'll start counting, assuming it starts at 0 here, but we might have to reset it every time it plays. So the green light comes on, the clock starts counting. Okay, has the button been pressed? Yes. Have we allowed enough time for the traffic to pass through? Now, in this time, we're going to ask a different kind of question. So instead of looking at the digital inputs on the switch, has a button been pressed? We're going to now ask, has the time passed a certain amount? So we're going to look at this compare question here. Now, we can use this for variables, which are things that change, obviously. Now, we'll get into variables in slightly more detail and further down the line, but for now, we're just going to use the variable time, okay, which is basically the number of seconds since the clock has started, whole seconds. So is time greater than, that's that symbol there, let's say, well, again, like I say, when you're doing a test simulation, you might not want to put the full 30 seconds in, because it'll just take ages to test it. So we'll just say 5 seconds. Has time got greater than 5? Okay, if it has, the button's been pressed and the time is greater than 5, then we can do the sequence. If it hasn't, you just have to carry on waiting. Okay, so we'll just carry on round in this loop until both of these conditions are met. Okay, when they're both met, then we can do the sequence and go back to green. Okay, now remember also, I mentioned here, we haven't got to reset the clock yet. So having done that, we need to put a reset the clock. So I've lost it on this list here, so I'm going to just copy it here, and paste it in here, and then change that to set the clock back to 0. Okay, if I didn't have this here, then this condition would still be met as I press here, because the time carries on counting. Even if you go round in a loop, it's still going to be counting up. So you need to be able to tell it to reset, and that way it'll just carry on counting from 0 each time the traffic light sequence has happened. So let's see if that works. Green is pressed. Now let's do it straight away. Nothing happens. Okay, 5 seconds later, now it works. Again, this is the kind of thing that you might want to just loop twice if you're just doing a test, because it can be boring waiting. Immediately after, nothing happens. And then after 5 seconds, it does. So yeah, add to that a slightly more accurate way of flashing, although this is pretty good. I think an A grade would want a red and a green man. The green man will come on slightly after the red light has come on, so you might want to just do the precise timing slightly more accurately, and the green man will be flashing as well as this yellow light. Now you might even notice they start flashing at slightly different times in a real life traffic light, so if you want to be really detailed and accurate about it, then just have a watch of a traffic light. They're all slightly different anyway, and you can get an exact A grade like that. Okay, one other variable is the random thing. Now, the second part of this assignment, you've got to make a dice. Now, I'm not going to wire up a dice. You might want to have a 6-sided dice, i.e. you've got 6 in a row, but you've also got 1 in the middle, so you've got 7 outputs. Now, you can do that on this 8 output thing, so that's not a problem. But the way you wire it is hopefully your initiative, how you can get something nice and good. But what I'm going to show you here, in this case, we'll just have a 3-sided dice here, just for ease. Now what I'm going to do here is, let's just go get rid of all this. Actually, before I do that, I'm going to just keep the button because I'm lazy. So D0 on, there you go. And then let's have all of these: green, amber and red. Okay, now they're on for a second as well, which is not necessarily what we want for dice, but it might be alright. Now we'll delete all of this. Right, now is the button pressed when we have our electronic dice? When you press the button, we're going to get a dice roll of 1 to 3. So one of these 3 is going to come on for a second. Now, what do we want to do here? When the button's pressed, we want to make a random number. And here we've got a special bespoke command, which is exactly that. These here are mathematical calculations, and they're really useful, especially this one, which I'm going to get onto in another video. But you can do all sorts of variables things. So you've got one type of variable, say the random number, which I'm going to call A. And we might want to say, okay, we'll add 1 onto that random number. So I'll call the random number 1, 2 or 3, and then we'll add 1 onto it, so it will be 2, 3 or 4. Not that we want to do that for this example, but yeah, you can do all sorts of things like that. So A equals, if you want to add 1 to A, then you'd say A equals A plus 1, and A will just get one amount added to it. You can also do that with this increment. And if you want to do -1, it's decrement. So this is quite a versatile thing. You can say A equals 3 at that point. Say for some reason you've asked the president, has this button been pressed? That means, okay, the LCD is saying, would you like to add 3 to your whatever it's doing? You can say at that point A equals 3. You don't have to use all 3 of these bits, but you've got a lot of variables. You've got 26 variables there, and you've got all sorts of other things, plus actual values up to 255. So it's a useful thing there. We're not going to use it for the dice though. We're going to use random here. Now here we've only got 0, 1 or 2, so we can say 0 to 2. That's 3 options, 0, 1 and 2, and we're going to say variable A. Okay, now how do we get each one light on depending on which number it is? Well, we use a compare here, like we did on the last one. Compare, is time up to the amount on the traffic light? Yes, it is. In this one, is A equal to 1? That's down there, or 0, sorry. Okay, if it is, put the green one on. If A equals, if it's not 1, it's going to be 1 or 2. Sorry, if it's not 0, it's going to be 1 or 2. Is it 1? Okay, if it is, we're going to put amber on. Now, we could do another one here. Is A equal to 2? And that's going to make the red on. Okay. You still need to have a no output, even though it's got to be 1, 2, 0, 1 or 2, because we've only generated something from 0 to 2. So it's going to be one of these 3. But still, just to make it work, it's not intelligent enough to know that it will cancel out the other options. So you need to have a return like that. And ideally you have it there so it doesn't generate another random number. However, you don't actually need to have that one, because assuming it's not that 2, it's going to be 2. Does that make sense? So if it's not 1, if it's not 0 and it's not 1, it's got to be 2, because that is there. So it will go through there anyway. And then once it's had its second on, then we want to have a return to do the whole thing again. Now remember, I'm going to deliberately make this wrong here. See what happens. See if those you eagle-eyed ones that can work out what I've done wrong. When I press play, okay, sorry, that's not what I was actually thinking was wrong, but there's something else wrong here. When I press play, we've got a random number. It comes off after a second, but it doesn't come off because we haven't told it to come off for a second. Okay, when I do that, see if we can get the green light. Yeah, we've got one there, but it just flicked on. Now it's just a bit weird that. What's going on? We have basically said turn this one on. We haven't even given it a time, so okay, that might be the problem because we haven't got a green light a second. Of course, yeah, when we were doing the amber and red on the traffic light, we needed a second there. I'm going to just have it on for 1 second, but also I want to turn them all off when it's done. So they're only on for a second and then they're all off like that. Let's see if that works better. It should do now. Amber and then it goes off. Amber and it goes off. Red and it goes off. Red and it goes off. I still haven't got a green one yet. That might just be a chance. Yeah, there we go. Took a while, but yeah, strangely we've had a lot of 1s and 2s, so it doesn't even seem that random, but it should be. Anyway, that is a very simple dice. You might want to do 6 outputs or 7 outputs if you're going to do the actual dice shape, and that's quite a straightforward program. Now, not that it works in real life with when you roll a dice. You could roll a 3 and then another 3 straight away. But it might be quite annoying. For example, in the helicopter game that I might demonstrate, you don't really want the same random number generated straight after you've flown to a random base. You don't want to then fly to that same base because you're already on that base. So how do we do that? Well, we have given this random number A, and we know what it is at this point. Now, we might want to say... get another variable. So in this case we are going to use this not compare question, we're going to use the expression command. Expression like this. Okay, now what I'm going to do here is to say A equals B. Why am I doing that? Well, sorry, I'm going to say B equals A. So B, the variable A, sorry, the variable B, this new variable, we're going to give it this variable, which is the last random number. So having done it, we're now just going to, let's just move this down so we've got space to put this in. Okay, my question now is, is B the same as A? I've just made B A, but now I've called a new A random variable. So if I get the same number again, we'll do this again. So we never get the same number again. And that can be quite useful. Not necessarily for a dice. So it's B A, right. So not necessarily for a dice, because you could get the same number rolled twice. But say for the helicopter game. Now, we're going to need to swap yes and no around, because if B is the same as A, I just want to call another random number. So yes, if B is the same as A, draw that random number again until you get a fresh random number, and then do that. And now we shouldn't have the same random number called. So red, yellow, red. It's funny it never gets green, but there you go, green, red. So you'll never get the same light on twice, because it's just checking if the last random number is the same as the next one. So hopefully in a few minutes we've given you quite a good head start how to use Circuit Wizard. You should hopefully see it's quite a straightforward way of programming, certainly if you're not a natural coder like me. It's a really nice just visual way of following a path as to what happens. So we talked about when conditions are met, introduce you into variables, all sorts of things. Now, for example, you might in your game want to press this button 10 times. And then after 10, something else happens. They all flash like the end of a go. Okay, so you might be using a variable. You're going to assign a variable, a equals 1, not a in this case, this is a random number, but let's say it's variable c. Let's put variable c here. So we're going to just go c equals 1. Now remember, you can also do this here with the set command, so you can set a specific bit in the variable to be 1. But I always use this expression command because you can do all sorts of things. You can make one variable the same as the other, you can add one to it, you can do all sorts of things with it. So it's a much more versatile thing. Just say c equals 1 there, okay, at the beginning of the program. Okay, so what happens here, on each time we press the button, we go around this loop, we're going to add one to the variable. So I'm going to increment, rather than using the expression variable, we just use increment variable c by 1. Now also, every time we go through this thing, we're going to ask another one of these compare questions. So just copy and paste that one. And this time we're going to look at c. Let's say, has it gone up to 5 yet? Okay. So if c is 5, so if it's not 5, we're going to carry on round and just keep going up until you've got to 5. Now when it's got to 5, then we're going to have an end game sequence. We could have a subroutine like we showed in the traffic light part just earlier, and you could flash all the lights. That's the end of a game or something like that. Hopefully that is enough tools to do quite a straightforward little game if you want to practice it, like a reaction timer. Who presses the button first? That's quite a straightforward one to do. Hopefully some of you might be able to work that one out. A couple more features that we could play with. Now we're going to go back to the original traffic light design here. Now let's just forget it's a traffic light, but we've got one button here, D0, that we press when we start it. Let's say if we copy that and we have a new button, this time D1. What I want to do is use this button to cancel the program at any time. Now think about it, where do we put this button? If we want it to happen at any time, it could go there. Well, basically it needs to go everywhere. And there are even times when, for example, a pause or a wait command here, if it was a command on its own, that effectively just freezes the program, so it's not going to be reading buttons whilst that waiting is happening. So what do we do there? Well, it's a form of it's quite a challenging programming in itself, where because programmable chips tend not to do two programs at once. They can't have two simultaneous things running at the same time. It's called parallel processing, and it's generally quite a difficult thing to achieve. There's kind of background tasks, but in this series we don't need to actually know about that. We just need to know how to use it. And what we've got these things here for is exactly that. We've got events and interrupts. Now, in the case of having a cancel button, we're going to use an event, and I can call it cancel here in the caption. The thing is, unlike subroutines, unlike subroutines, we're not actually going to give it a name and call that name. We're actually going to give it a number. Now here we've got up to 4 events, so we'll call it number 1. And with interrupts, we've got 5 to 8. Okay, so you can do 4 events and 4 interrupts simultaneously in a program. And also, if you notice here, instead of using a question button here, we just ask whether the input's pressed once there. So what happens there? Well, let's just say it goes back to the start here whenever it happens. Now also, you might notice here it says enabled here. So you can actually kind of have it not working yet at the beginning, and then use an enable or a disable thing here. So here I'm going to say, well, it's the event one, which we're using anyway. You can see it's there. Or you could enable all events and interrupts at that point, switch them on, and then have the same. So we'll do that here, enable all, and then use the same command here to disable at the end, let's say. Oop, if I can fit it in, let's just move that up. There we go. And then uncheck that, and it's disabled. Okay, and that obviously we might want to just enable, because this is enabled, this one in itself here, like that. And I might just want to enable the interrupt. Anyway, it's just one way of controlling specific interrupts and events. So that means when we press play, okay, I need to just get rid of that one for now. When we press play, and we'll use the inputs and outputs. So if at any point I press input 1, it just goes back to there. Now just bear in mind, if I hold it down like that, it'll just keep getting stuck as it starts. So you might want to have a is the button released before it comes out, or just a little pause just for a few milliseconds. Okay, so that's an event. And then an interrupt is exactly the same. The only thing is it's more like a subroutine. So in other words, you might, let's say, as a penalty in the game, if you're making a game and you touch the penalty button, or penalty area, you hit the penalty area, you might have this flashing amber as a kind of penalty thing. So instead of doing that, we'll have an interrupt like that, and we'll say that's when button 2 is pressed. So this time, okay, let's just use this one again. So I'm going to press input 1, and it's going to do there, but at any point I press that and it goes into interrupt like that. So it'll immediately say you just press the button and the alarm bell to go. So that's quite a good way of doing a simultaneous process in the background at any point. Now that's an input, and you wonder if you can kind of constantly have a flashing light as an output, for example. Yes, you can. Now it's a bit of a kind of bodge. It's not really for what it's meant for, but it seems to work fine. And that's to use something called a pulse. So it just sends an output continuously. Now you might just be able to send, this will basically send a single output on whichever output there for however long. Or you can have a pattern here, which is probably more likely. If you want kind of flashing LEDs going on in the background at any point of this, then a pattern is quite a good way of doing it. It's a bit of a kind of long-winded way if you've got to draw out your patterns. So let's just say we've got 4 lights off, and then I'm going to have another one, and then this one's on, and you can see it will add where the cursor was. So yeah, whatever, if you've got some kind of pattern going on like that, name it here, give it my name, and then again, each of those pulses needs to be counted in a whatever length of time you want. Actually, notice here you can use variables. So depending on, you can set the speed of that pulse going on in the background just by choosing a menu option and kind of incrementing variables or decrementing them, whatever you want. So yeah, that's something that you can do in the background. Let's just put that like that, and then we can either have it on in the background like that, so it just keeps going, which is effectively a parallel process, until you turn it off. So you notice here, repeat until task stops, and that will be using control, I think. No, stop task, sorry. So until you've got that command, so I might have that at the beginning, like that, and then at the end of it, let's just see what happens there. So this won't actually show in here, but it does go on in the background. every 100 milliseconds. So 10th of a second you'll have that pulse going on until this command is met, and then it will stop, and then it will start again there. So yeah, that's two quite crude ways of doing inputs and outputs going on in the background. They're quite useful.